The next method for solving systems is the elimination method. In the elimination method, we are trying to get one of our variables to eliminate. We're trying to get rid of one of them. You can only solve an equation if you have one variable in it. So when we did the substitution method, we substituted to get only one variable so that we could solve it. This time we are going to add the two equations together, hoping that one of the variables will go away in the process and leave us with an equation that we can solve. I think in the past, some of your teachers taught you addition, some of your teachers taught you subtraction. Personally, I think addition is easier because I just don't really like subtraction very much, so I tried to use addition. When we're using the addition method for elimination, you want to have a positive-negative match. So first of all, you have to make sure that your equations are lined up with the x's lining up, the y's lining up, and then the number after the equal sign lining up. So number 5, it's perfectly lined up. Then you want to either cancel your x's or your y's. So in this first example, we have positive y in the first equation and negative y in the second equation. This one is perfectly set up for elimination. We add these two equations vertically. What is x plus 2x? 3x. Y plus negative y, they cancel each other out, leaving you with nothing or 0. You don't have to write the 0. And then 2 plus 7 is 9. Can we solve the equation 3x equals 9? Yeah, divide both sides by 3. X equals 3. So our solution here is going to have an x value of 3. To find your y value, you have some options. You can plug 3 into your top equation or your bottom equation. This is where strategic laziness really comes into play. Which of those two equations looks easier to deal with? The top one. X plus y equals 2. So 3 plus y equals 2. So y is -1. That's messy. Okay, number 6. First of all, what the heck is wrong with number 6? It's all messed up and messy looking. So the first thing that we need to do is rearrange whichever equation is messed up so that it's not messed up anymore. So I'm going to recopy my top equation because that one looks exactly like I want it to look. The bottom equation doesn't look so good. What should we do on that bottom equation? Add x to both sides and add 8 to both sides. So we're doing two separate things to end up with x plus 4y equals 8. Okay, we just did two steps at once. So the x was on the wrong side, so we added x to both sides. That -8 is on the wrong side, so we added 8 to both sides. And that rearranged it and made it nice. So our other equation is x plus 4y equals 8. If I added these two equations together right now, would one of our variables eliminate? No. It's not ready for elimination. We need to do something to get it ready for elimination. Anyone have any guesses? Multiply everything in one of the equations by -1. That would give us a -x and a positive x. So our goal here is to get, and I'm going to write that right up here. Our goal is to have positive x and -x, or -x and positive x. It doesn't matter which one is which. I'm going to multiply the top one by -1. So that will give me -x minus 3y equals 5. And just because I'm kind of redundant, I'm going to rewrite the second equation right underneath. Negative x and x is 0. They eliminate. Negative 3y and 4y is 1y. By the way, this 5 should also be negative because the biggest mistake that people make with this is that they forget to multiply to everything in that equation. So good catch by my class. That definitely needs to be equals negative 5. And then when we finish adding these together, negative 5 and 8 is 3. So we know that y is 3. You've got some options for x. I would choose the equation that looks the easiest, the smallest numbers, no negatives if possible. I'm going to choose the original top equation to plug my x into, or to plug my y into. So I have x plus 3 times 3 equals 5. Our solution is negative 4, 3. Number 7 has a couple of options. I see that we've already got a positive negative, so we could probably make the top be positive 6x and the bottom be negative 6x, but that would involve multiplying both equations, and if we can avoid that, we should. I see that that y, the top y, is just a 1y. So what do we want that top y to be? Negative 3y. So we'd have to multiply the entire top equation by negative 3. So negative 9x minus 3y equals negative 18. Make sure you multiply that to all three things. The bottom equation we are not changing. Now this is perfectly set up for elimination. Our y's are positive and negative matches of each other. So add them. What's negative 9 plus negative 2? Negative 11x. The y's eliminate equals negative 16. This doesn't look good, does it? No. Divide both sides by negative 11. So x equals 16/11ths, which quite frankly, let's write that as a decimal, 1.45. So if the first part of our solution is 1.45, we need to plug 1.45 in. We definitely have some options. You can plug it into the original top equation, the new top equation, the original bottom equation. Which one looks the smallest, the easiest, with the least negatives? The top original. So 3 times 1.45 plus y equals 6. 3 times 1.45 is 4.35. $1.65. That's an ugly looking box. Okay, number 8, we don't have to solve this all the way, just to give you a little bit more work time on your assignment. But as of right now, my x's are not ready for elimination. My y's are not ready for elimination. The only thing that's really good about number 8 right now is that the x's line up, the y's line up, and the numbers line up. So it looks good, but it's not ready. There's some options. The other difficult thing is that everything is positive, so we don't have a negative already glaring at us. Should we tackle 2x and 3x or 4y and 5y? Go for the smaller numbers if possible. And our goal here, think about 2 and 3. What number pops into your head when you think of 2 and 3? 6. So we really want this top one to be 6x and the bottom one to be negative 6x. Or the top negative 6x, the bottom positive 6x. As long as one of them is positive, one of them is negative, you're good. On the top, if we want this 2x to turn into 6x, what do we need to multiply by? 3. So multiply by 3. We get 6x plus 12y equals 9. On the bottom, if we want positive 3x to turn into negative 6x, what do we need to multiply by? Negative 2. So keeping that goal in mind can be helpful to know what you need to multiply by. Minus 10y equals negative 2. Now this is ready for elimination. The x's eliminate. 2y equals 7. Another decimal. Don't be worried if you get decimal answers. That sometimes happens. That's why we solve these using elimination or substitution and not graphing. Because if we had to solve these by graphing and then deal with the decimals, that would be tough. When you go back to find x, you have 4 different places where you could put that x. I'll highlight them in purple. You could plug it in here, or here, or here, or here. Pick the equation that has the smallest numbers and the least amount of negatives. So I would probably plug into the original top equation. 2x plus 4 times 3.5 equals 3. Do you all feel like you'd be fairly good at getting that x value if you had to? So you would then finish this problem, yada, yada, yada. Now, reminder, with elimination, if you are adding your 2 equations together and you end up with 0 plus 0 equals 0, if all of your variables eliminate and you're left with a true statement, that would mean many solutions. If your variables all eliminate and you're left with a number, does 0 equal 7? No, that would be no solutions. So same kind of rule like we had during the substitution. If your variables eliminate and it's true, many solutions. If your variables eliminate and it's false, no solutions.